Hello all, I am Miss Amrita Zadhav ma'am, your physics teacher, and we are doing a chapter electrostatics, we are here with the part 3. We have seen part 2 of the same chapter, in which we have covered many concepts like Gauss's theorem and potential energy that we have covered. Now, as we said yesterday, that we are going to deal with the more relations which are regarding to potential. So today's lecture is about potential itself, but it is due to some conditions. Okay, so let's start with today's session. Before starting, let us revise what we have done in the previous lecture. So what we have done in previous lecture, yes, we have seen the expression for potential energy. What is the expression for potential energy that we have derived by using a diagram which is containing a point charge which is located at some distance. Then we have derived the equation or the formula as 1 by 4 pi epsilon 0 into q1 q2 by r. That was the potential energies formula, which is denoted by ur. Then we have seen the units of potential energy. What was that? Unit in different systems we have seen. In SI we used to say it as joule. In CGS it is erg, or we can convert it into electrovolt, EV. Alright, so we have seen the definition of 1 electron volt also, and have seen the relationship between electron volt, and even we have seen the relationship between, if it is a millivolt, if it is a kilo electron volt, what should be the conversion between that to the joule, that we have already seen. I am considering that you have all cleared the doubt about potential and the units of it. Then we have seen concept of potential. What is the concept of potential that we have seen? In that we have derived a new formula which is distinguish between potential energy and electrostatic potential. There is a huge difference between potential and electrostatic potential. When we deal with electrostatic potential energy, it is denoted by U. When we deal with electrostatic potential, it is denoted by V, which is nothing but U upon Q. Alright, or it can be written as W by Q. So this is all we have seen in this. Then again we have seen the relationship between electric field and electric potential, which is minus dV by dx. E is equal to minus dV by dx. What is the negative sign indicates? A negative sign indicates that the electric field at a point is always negative of the potential gradient. And what is potential gradient? It is dV by dx. So this is what we have learned. And the last point, which is zero potential, we have seen the example which is earthing. What is meaning of earthing, or what is meaning of grounded? The point which is located at a very larger distance from the conducting point. When it is at very larger distance, it will not have potential. The potential will be very less. So that is called as zero potential. So electric field will not be there. We are going to deal with the same concept in the next derivation, which we are going to deal today. So you will come to know the exact idea about zero potential. So let's move towards today's session, in which we are going to deal with some new concepts regarding electric potential. The first, see, we are going to see only 3 points today, because these 3 points are the derivations. So you must have to be concentrated towards the lecture. Don't just skip. Have patience and be calm and be concentrated while we are doing these 3 derivations. All of 3 are very important derivations. They asked in board examinations. So you have to prepare all of 3. You have to prepare, or you have to by heart the formulas of it. So please be concentrated towards it. Okay, so let's move toward. I am hoping that you are very calm and you are being concentrated towards the lecture. So by considering that I am moving towards the lecture, and in which we are going to see the points. First is electric potential due to a point charge. We are going to calculate the potential which is at a point charge. Then due to electric dipole. Then due to system of charges. So these 3 points are related to only electric potential. First we are going to find out due to point charge, due to electric dipole, and due to system of charges. So let's see what is the first one. So here is the first point. In the first point, electric potential due to a point charge. Have a look inside a diagram in which you will come to know the exact idea about it. Point O is a point where a charge is located, which is plus Q. Okay. A point is a midway point which is at a distance R. M and N are the 2 points. I am going to explain what are the 2 points over there. And E bar is the electric field intensity which is going along with the line, and X is the distance between O and M. Okay. Now we are going to determine potential at point A. Here is the point where we are going to find out the electric potential. Alright, which is located at a distance R from a point charge O. When we are going to find out a potential at point A, we need to do some work done so that it can displace from infinity to point A. Okay, the point is situated somewhere else. From that point we are going to take the charge at point A, which is at R. Again I am repeating, suppose charge is over here, suppose another charge is here. I want to place this charge up to A. Okay, and to take this charge up to A, I will require some work done to displace that charge from some distance to A. So I am considering that this point which is here, it is at a distance infinity, and I am going to take the charge from infinity to point A. So work is done over there. Okay, so we choose convenient path when that point charge is carried from infinity to point A. So now M and N are the intermediate points between that path. So M is the point, it cannot be directly find out from infinity to A. It should take some displacement in between. So if the M is the intermediate point which is at a distance x, then what will be electrostatic force which is at point M? What will be that? Electrostatic force is derived by Coulomb's law. So it should be F is equal to 1 by 4 pi epsilon 0 Q upon x square. Alright, because charge is Q over here and distance is what? X. So this is Q by x square. If I am saying some work is done to carry that charge up to point A, so work done is nothing but force into displacement, and work is against that field, as the field is over here and we are moving that point in this direction. So these two are in opposite direction. So we are getting dW as minus F dx. Now this is dW, that means very small displacement or very small work done which is between these 2 points. But I want to be whole. So what will be that? So total work done in displacing the unit positive charge from infinity to point A, what will be that? It should be integration. So I am going to integrate this equation. So what we are getting over here? So it should be in the limit. What should be the limit? From infinity to R. So lower limit is infinity, upper limit is R, and F dot dx. By taking out the negative sign, we are getting, instead of f, I am writing this term, which is this. Now again, as we have seen in earlier lecture, 1 by x square, this 1 divided by 4 pi epsilon 0 and q are constant terms, and integration of x raised to minus 2 we are going to calculate. What will be that? It will be minus 1 by x. So let's see what we are getting over there. Here, as I told you, it will be minus 1 divided by this. Okay, here I am saying. But this negative sign and negative sign of the integration will get cancelled out and it will get plus 1. So, and by putting the limits in that, we are getting q by 4 pi epsilon 0, 1 divided by r, which is upper limit, minus lower limit is minus 1 by infinity. As 1 by infinity is what? 0. So, we are getting w as q divided by 4 pi epsilon 0 r. So, by definition, this is the electrostatic potential at A due to charge q. Okay, so V is nothing but q by 4 pi epsilon 0 r. If r is equal to infinity, what will be V? V will be 0. That is nothing but 0 potential. That's what I am telling you. When it is displacement, or it is placed at very large distance, that is infinity, then if it is at infinity, potential will be 0. Okay, so this is nothing but the derivation about electric potential due to point charge. Fine. Be calm. You have to solve it on the page and then you will come to know what exactly it is. Okay, don't just watch out the video. You have to write down this derivation inside your notebook and try to solve it 2-3 times. Then and only then you will get this concept. Okay, now here is the graph I have seen. What is that exactly? It is relationship between electric field, electric potential and distance. There are two graphs which are intermediate. Two are in a same graph. First is variation of electric field and potential with the distance. Dotted line, dotted graph means this graph. This dotted will give you relation between V and R. That means electric potential and R. And then fixed one which gives you relationship between electric field and R. From this graph we can say that due to single charge at a distance r, F is inversely proportional to r square. This is actually due to Coulomb's law also. And electric field E is also inversely proportional to r square. But potential is only inversely proportional to r. You can get from this equation also. Not to worry about it. From the formulas you can say that. From the Coulomb's law you can say F is inversely proportional to r square. From this formula you can say V is inversely proportional to r and E is inversely proportional to what? R square. So you have to remember this. This can be asked in MCQ type of questions. Okay. So I hope you got all the derivation. Try to solve it by your own 2-3 times, at least 2-3 times. So let's move towards the next one, which is very hard to understand. So be calm while doing this. Okay. Now we are going to find out electric potential due to an electric dipole. You must have seen the concept electric dipole. When two charges are situated at distance or separated by distance 2L and one is having plus charge and another is having minus charge. So this A and B, one is having plus charge and another is having minus charge and they are separated by distance 2L. When I cut it into a similar forms, it will be L and L. Okay, now electric dipole, which is AB, consisting of two charges plus Q and minus Q, separated by distance 2L, that we have seen. Its dipole moment is P bar. Now what is the formula for it? Formula for dipole moment is P is equal to Q into 2L. Okay, it is P is equal to Q into 2L. Now the line joining the center of two charges called dipole axis. The line joining the two charges is called dipole axis. Fine. Then a straight line drawn perpendicular to the axis passing through center is called equator of dipole. A straight line drawn perpendicular to the axis, here this is axis, suppose the perpendicular line which is drawn to the axis and passing through the center, here it will be equator. Alright, in order to determine the electric potential due to this, that means due to dipole, origin to be at the center, which is O over here, here it is. Now we are going to consider a point which is very near to the dipole, that is C over here. C is the point which is situated at a distance R from center, which is O. Okay, it is inclined by an angle theta. Here you can see angle theta with the axis of dipole. R1 and R2 are the distances of point C from A and B. I am saying it very slowly because you have to know all the things which are related to diagram. Alright, now potential. I will explain the diagram again. A and B are the two. A and B are what? Dipoles. One is having plus Q, another is having minus Q charge. They are separated by distance 2L. O is the center, so this will split into L and L, right? Now this is the perpendicular which is drawn to this, and here from B another potential perpendicular is drawn over here. We are going to name something over here. Then point C, it is at a distance R from the center and it is inclined by some angle. Here is the angle. Okay, and R1 and R2 are the distances from A and B of C. Okay, now we are going to find out individually the potential for C due to A, potential for C due to B. What will be for A? It will be 1 by 4 pi epsilon 0 into plus Q by R1, obviously, because the distance is R1. Due to B, it will be what? It will be 1 by 4 pi epsilon 0, but it is minus Q divided by R2, obviously. So it is for V2, it is minus Q by 4 pi epsilon 0. Now in addition it will be V1 plus V2, obviously. So here you are getting the another equation. One is having plus and one is having another. I am repeating again and again so that you will come to know exact idea about it. So this is the equation what you got. Now we don't know the value for R1 and R2, so we have to find out value of R1 and R2. To find out this, you have to be patient and you have to be concentrated, because we are going to use some trigonometric functions inside the diagram. Okay, so let's move to the previous slide and we will find out value for R1 and R2. Okay, so let's see. Here is the diagram. In this diagram, let's see, we have to find out R1 and R2, right? Now if we say, if I am saying this AC and about CN, what is the exact relation between them? What is the difference? Are they equal? Are they equal? No, they are not equal. Why? There is some distance, or there is some lag of the length. There is some decrease. Here this length is in smaller size and this length is in bigger size. I have to find out the distance between both of them. Now there are many tricks by using which we can find out the difference between two lengths. If it is very smaller, that means like this, we can use a very simple process by which we can find out the distance or the exact relation between both of them. To find out the relation between them, we are going to draw a perpendicular to it. If we draw a perpendicular to it, it will create some angle. If this is R1, this is up to this point, it is something else. Suppose it is N, here is A. Alright, so here angle which is theta, I don't know the value for AN, this is L. I have to find out AN as well as OM. I don't know values of both. Even I don't know value for R1. So let's first find out what is AN. If this is theta, what will be sine theta over here? Sine theta is nothing but opposite side divided by hypotenuse. This is hypotenuse. If this is 90, this is hypotenuse. Opposite side will be AN divided by L. So what will be AN? It will be L sine theta. So we are getting AN as L sine theta. By using similar, this is nothing but L cos theta. And in a similar way, we have find out here also L cos theta, which is not given in the textbook. So you have to consider this point. How we have calculated this. Sin theta is nothing but opposite side divided by hypotenuse. So we are getting this length as L sin theta, and by using the same method we have calculated this, which is L cos theta. Now I am going to conclude that this CA and CN are similar. Which length are similar? CA and CN are similar. But what is CN exactly? If I put it N over here, CN is nothing but CO minus ON. Is it? Yes. And if I consider in the case of B, this is in the case of A, right? In case of B, if I say R2 is similar as CP, then what will be that? CP is nothing but CN plus NP. Are you getting what I am trying to say? C is the point which is located at some distance R, and R1 and R2 are the both different distances from both the dipoles, right? And we are going to find out value for R1 and R2. So to find out R1, I am considering this is similar to this length, if we consider A. So this is nothing but CO minus ON, and for this dipole it will be CN plus NP. In a way it is plus for A, and for B it will be minus. Alright, and what is this? This distance, this distance is L cos theta. Okay, now if you consider this, then you will come to know exact idea about this. Then what will be R square over there? What will be R if you are getting R as, what you have got? R is nothing but R minus L cos theta, that we have got, right? And R2 we got R plus L cos theta. Your theta is there. For R1, that means for A it is minus, that we have seen, and for R2 it is plus, by squaring the terms. if I square this, what you are getting? R square plus L square cos square theta minus 2RL cos theta. And for second one, R square plus L square plus twice RL cos theta. But here are the terms only considering L square, not cos square theta, because as you see the diagram, theta is very small, so we can consider cos square theta as a negligible content. So we are going to neglect the cos square theta term. So we are getting only R square plus L square minus 2RL and R square plus L square plus 2RL cos theta. Okay. Now what is the next is, we are going to common out this R square from this equation by taking out R square common. By taking out R square common, we are get over here, it will be 1 plus L square by R square minus 2L by R cos theta. Similar to R2, R square into bracket 1 plus L square by R square plus 2LR cos theta. Now we know value for, we want value for R1 and R2 only, not R1 square and R2 square. So we have to take square root of both of this term. So by taking square root of both of this term, we are getting like this. The another extra term is, as it is a short dipole, 2L is very less than R and L by R is small, so L square by R square will be very small. So we are going to neglect this, both the terms. So we are getting only two terms. R1 square is nothing but R square into bracket 1 minus this term and this. Now this will be easier to find out the square root. It will be R and square root of this, R2 and square root of the bracket. Now we want value for 1 by R1 and 1 by R2. So by taking reciprocal, 1 by R1 will be 1 by R, this raised to minus half, and the second one raised to minus half. By putting both the values in this equation, we got this. What is that? Q by 4 pi epsilon 0 will be common, and this is it. Even 1 by R is common, and we are going to do some relation between this both. Let's see what's the relation between them. Yeah, those who are having maths, it will be very easier, some kind of easier to understand this. If you are not having maths, please do practice for 5 to 6 times. The next one, using binomial expansion, 1 plus x, it is raised to n over here, raised to n. Okay, so it will be 1 plus nx. Here it is raised to n, alright. Now by using that relation, we are going to do Vc is equal to q by 4 pi epsilon 0, as 1 by r is also a common term. So by taking out, we are getting 1 plus L by r cos theta. How 1 plus L by r? Here, what is that? 2L. By binomial theorem, this minus half will be get multiplied over here. If minus half is multiplied over here, minus half into 2L cos theta. So this 2 will get cancelled. It is having only L cos theta. In this also, minus half is get multiplied to 2L cos theta. 2 will get cancelled. So in that way, we are having this two terms. So raised to get cancelled, it get multiplied by using binomial expansion. So you are getting this by separating out all the equations, by taking out the bracket. So this 1 and 1 will get cancelled, and you are getting L by r cos theta and L by r cos theta, which is nothing but 2L cos theta by r. Now what is q into 2L? It is nothing but p. So Vc is nothing but 1 by 4 pi epsilon 0 p cos theta upon r square. Now we can put the values for theta as 90, as 0, as 180, and we can find out the values for V. If it is 0, if it is 0, what will be cos 0? It will be 1. So you are getting equation as this. That means it is at axis. So this is the maximum value of potential when theta is 0. Even this can be asked in exam. If theta is 0, you are getting the maximum value of potential, which is V is nothing but P by R square into 1 by 4 pi epsilon 0. If it is 90 or 180, not 180, if it is 90, it will be cos 90 is 0. So you are getting V as 0. So this is the minimum value of potential when it is at equatorial line. Maximum value is P by 4 pi epsilon 0 R square, and minimum value is 0. When you are getting maximum value when theta is 0, and when theta is 90, we are getting minimum value, which is 0. So this is the expression for the dipole. Now moving towards the another point, which is electrostatic potential due to system of charge. Now we are just going to consider many number of charges and we are going to add up them. So here Q1, Q2, Q3 up to Qn, there are number of charges. What is V1 for first one? It will be 1 by 4 pi epsilon 0 Q1 by R1. For V2 it will be 1 by 4 pi epsilon 0 Q2 by R2. Similarly we can apply up to Vn. And what will be the summation of it? It will be this. By summing them out, what will be 1 by 4 pi epsilon 0 is common, and we can write summation Qi by Ri. So this is the formula for number of charges is considered. So this is the final expression for this. By using superposition we can say this and this. Okay. So this is all about today. We have just seen 3 derivations and you have to do all of 3 or 4 times. Then and only then you will come to know exact idea about it. Okay. So what points we have covered today? Electric potential due to point charge, electric potential due to electric dipole, and electrostatic potential due to system of charges. These are all 3 points we have covered, and this ends the lecture. Thank you so much for watching, and if you have any query, you must have query for this part, do comment. I will try to solve your query. Thank you so much.